Hello, and welcome to the Redis Enterprise Virtual Workshop, Building Performant Applications with Redis Enterprise. We appreciate your time today and look forward to a great discussion. Please use the Q&A tab to submit questions or type them into the chat. We also have a few polling questions to understand where each of you is on your Redis journey and which additional workshops you are interested in attending. We will send out a recording of today's session together with additional resources next week. And now I would like to introduce today's speakers, Al Cole, Vice President of Professional Services at Redis, and Tom Solon, Professional Services Training Engineer at Redis. And now we have a couple of poll questions to make today's session interactive and fun for everyone. So we'd like to know, what is your experience level with Redis? Some of you may be just starting out on your Redis journey. Some of you might have not used Redis before, and others of you might be intermediate or advanced users with Redis. So this will just help Al and Tom as they go through today's workshop to understand where each of you is and to highlight different things as we move forward through today's workshop. So we'll give everyone just a moment to respond, and we really appreciate all of your participation. Thank you in advance. So now we'll move on to our second question. So which caching solution or solutions are you currently using in your organization? Some of you might be using Redis Enterprise, others might be using Redis Open Source. Others of you might be using Google Cloud Memory Store or Amazon Elasticache. So this will just help us understand which solution or solutions you might be using, or you might not be leveraging a caching solution either. So completely fine. And we appreciate all of you joining us today. So thank you very much. So I will end that poll. And then we will go to our third question of the day. So which search solutions are you currently using in your organization? Some of you might be using Redis Search or Elasticsearch or OpenSearch, Lucene or Solr. So this will just give us an understanding of which solutions you're using. We'll give everyone a moment to respond. And then we'll move on to our final poll question before we hand things over to our presenters. So our final poll question here before we move on is, which additional workshops are you interested in attending? So we have an admin operations virtual workshop, a Redis Enterprise Session Management and Data Caching virtual workshop, a search solutions virtual workshop, a Redis microservices architecture virtual workshop. And we do have a Redis ML and AI virtual workshop as well that I don't see as a response on the poll question. But if that is of interest to you, feel free to type that into the chat and we will definitely send you information on that as well. So we'll give everyone just a moment to respond. Excellent. Well, thank you all for your participation, and Tom and Al, over to you now for today's workshop session.
All right, thank you, Janelle. My name is Tom Solon. I am a training engineer here at Redis. Welcome to the Redis Enterprise Virtual Workshop, Developing Performant Applications. What we're going to talk about today, Redis Enterprise capabilities, then programming with Redis database, including the data structures, transaction handling, JSON modules, and I'm going to give you a demonstration of an app he put together that brings these functions together. It starts Redis, and there's Redis. So Redis started as an open source database, in-memory, NoSQL database. It still is. Redis, the company, and Redis Enterprise is basically, if you think of Redis open source as the engine, then Redis Enterprise is the car built around it to provide the additional functionality. Terminology. standalone open source Redis process is known as an instance. The instances, if they are part of a cluster database, are typically called shards. So these shards then can be distributed across one or more nodes. This allows you to divide your key value pairs among shards and scale your data. So in the example shown in the slide, you've got 1 million key value pairs, 4 shards, so each shard is servicing approximately 250,000 of those. So starting from that Redis instance then, the single-threaded open source database, they will always have a designation as either a master or a replica. Again, we usually call those shards when it's part of a cluster database. The Redis Enterprise Database then is the logical entity that manages your entire data set across multiple Redis instances. This is the layer that segments the data into shards and distributes them. And we have the Redis Enterprise node, which are the physical, virtual machines or containers on which the Redis Enterprise is running. Bunch of nodes together, Redis Enterprise cluster. Allows you to pool system resources across the nodes in the cluster, supports multi-tenant database instances, in general, helps reduce the total cost of ownership. So let's look at an individual node. Now in this diagram, what we're showing are the 2 layers, the enterprise layer in blue, and beneath it, the open source layer in red. As I mentioned, enterprise is built on top of the open source. So you've got the same sub-millisecond latency that you're used to for open source, including whatever integrated modules you may be using. But then the enterprise layer also adds the data proxy, a cluster manager, and a REST API. So to scale with Redis, you simply add another node, and another, as many as you need to handle all of the data that you have. So once again, the benefits, the whole idea is we're a shared nothing architecture, which means every node is running every process that is needed. That allows you to have a multi-tenant cluster, actual separate databases, independent, optionally including separate users, roles, access. This is not just segregating namespace like in open source. You could have a dev, a test, a prod database without exposing production to developers or testers. It's very well suited for microservices, capable of running hundreds of shards on a single node, gives you shard isolation and protection, simplifies rebalancing, and maximizes utilization. Let's look at these 3 primary components. The DMC proxy, that's the data management controller proxy, the cluster manager, and the REST API, starting with the data management controller proxy, DMC proxy. This is a big enterprise add, all right? It manages long-lived, persistent connections with each database shard, allows database endpoint multi-tenancy. So in other words, these proxies can service multiple databases, like I was talking about a moment ago. The proxies are multi-threaded and therefore can take advantage of multiple cores on your machine. It also performs just-in-time instruction pipelining and multiplexing. Let's take a look at those basic concepts. So every client only needs to know this one endpoint, the fully qualified domain name, FQDN. The proxy then takes care of routing the request to the right shard. All right, so your client code you write with the fully qualified domain name and port number, and then the proxy sends them to the right shards. The benefit of pipelining is you could have requests even from different client apps coming into the proxy, and since the proxy knows what shard hosts the data for those requests, it can group together all of the requests that go to the same shard and send it once. So you're only paying that ever so brief but non-zero network latency once for, in this example, 3 requests. And then it also gathers the responses, queues them up, and divvies them out to the right client. Another enterprise-only feature is this replication. So here, I'm not talking about individual shards. That's part of it. I mean, that's included in it. But here, I mean, you can replicate the entire database. So for example, you could have an active-passive arrangement where all of the reads and writes are going to one cluster. But you have another cluster, presumably off-site, which is backup. So if the main site goes down for whatever reason, or that zone in the cloud or whatever, you've got the backup instance that you can either bring up and redirect traffic to that, or use it to repopulate your database once you're back up and running. Another option is active read replica. With that, all of the writes go to one side and get replicated to the other side, but your reads are distributed. This allows you to give local latency for reads. So for example, you could have a cluster on the East Coast and a cluster on the West Coast, or a cluster in North America and a cluster in Europe, and even another cluster in Asia and another one in Africa, whatever works for your business needs. Last but not least, active-active. So similar to an active read replica, except now all participating clusters, and you can have up to 5, so you can have 1 on every inhabited continent, if that meets your business needs, is accepting reads and writes. So local latency for all your apps, all of your clients, all of your customers, and then the active-active database takes care of the replicas from any direction, so that all of the databases are kept in sync. Now let's talk about the master replica cluster architecture. So again, remember, Redis is using a shared nothing architecture. So every node has everything it needs to do the job of master of the cluster. One node in the cluster will always be the master, designated that's where all of the management happens. But because every node has the software and the processes running, if the master node goes down, another node can take over, and in fact will. There are 2 types of nodes, a data node and a quorum node. Let's take a look at the difference. So a data node is, surprise, surprise, provisioned for proxy and shard data operations. It, of course, can be elected master of the cluster, and it does participate in cluster quorum and in quorum votes for a new master node if the current master node goes down. This is the default node type when adding a node to a cluster. But there's also a quorum-only node. So this is provisioned for cluster operations only. Notice there's no red box up here for data. Now, the quorum-only node can be elected master of the cluster and participates in cluster quorum, because master of the cluster isn't about servicing data. It's about management, and this can do the management job. All right. Now, if you want a quorum-only node, it needs to be explicitly assigned either in the RL admin CLI or through the REST API. Why would you want to do that? Well, the only reason, the main reason, I would say actually the only reason to have a quorum-only node is so that you have an odd number of nodes in your cluster to break ties. So quorum in Redis open source is done with actual copies of the data. So you would have the master shard servicing the reads and writes, and then 2 or more copies. So if there's a network split, let's say down here, these 2 shards say, well, we're in the majority. We're confident in our data. One of these can be elected master and start serving requests. The downside of that approach is every node has to have all of the memory necessary to run the shards. With enterprise, we do quorum by node instead of by data shard. So if the same network split happens, this says, okay, I still have 2 nodes. We're in the majority. We can do business, and R1 will be promoted to master. The benefit of that is shown graphically here. Let's say you've sized it and you need an R4 4 extra large for your data. Your quorum only node, you can get away with an M4 large. What's the difference? Well, I looked recently at the AWS on-demand prices, and R4 4 extra large is a little over $1 an hour, about $1.06 an hour. An M4 large is 10 cents an hour. All right, do the math. Big savings. So we still have the data replica shards, of course, because that's what's giving us the high availability. So here's an example of what we start with normal operations with replica high availability turned on. Then if node 1 fails, of course, the replica shard gets promoted to master. So now it can do its job. And the master shard, once the timeout, once the wait period, the grace period expires, it makes a new replica shard, just in case there's another failure. Eventually, node 1 returns, comes back. We've got a happy database here. We're not going to change it. So node 1 is welcome back into the cluster, but we don't shift shards around just so that it gets, so it can feel good. Another backup, another thing that can save your data is persistence. So the way we handle persistence in enterprise is off of the replica shard. That way, the processes that are serving the request, the active requests from clients, is not bogged down with the whole disk IO replication process. So let's say you've got this situation with persistence, but both of these nodes go down. Now, you have also lost quorum. You've lost your data and you've lost quorum. This database is no longer servicing data, but at least your data isn't lost. One node 1, or let's say node 1 and node 2, the system, the data management controller recognizes that, oh, I have an empty database, but it shouldn't be. I have a copy of that data on disk. It restores the data. And then once the data is restored to the master, it starts replicating to the replica shard, which will then start updating the persistent storage. And then there's Murphy's Law. Anything that can go wrong will. What if you lose an entire server rack or an entire cloud zone? No problem. If you have rack zone awareness turned on. So what we're showing here is a hypothetical situation, still one database, 4 shards, each of which has a replica, where node 5 is the master shard. All right, so a server rack is not a master. A node is, not a master shard. This is the master node. Let's say this whole rack goes down. Somebody trips over the cord, a meteor hits, whatever. The first thing that's going to happen, we still have 6 nodes running. That's quorum. That's a majority. So the system is first going to elect a new master. Let's say hypothetically it's node 9. The new master is going to see that we don't have a master for shard 2. So it will promote replica 2 to a master. That will then create a new replica for itself, and so will any other master shard that used to have a replica on the down rack. And so through this whole thing, you've been out of commission for a millisecond or so, because it doesn't take long to elect a new master. Once you've got a new master, it takes care of getting things up and running again. Now, both the open source and enterprise use append-only files for better durability, where durability, I mean recovery up to the latest possible point in time. And they are configurable. So you can do it every write or every second. In other words, you're not really concerned about loss of data, and so you will accumulate writes for over the course of 1 second and then batch persist them. As I mentioned before, the default behavior in enterprise is to use the replica shard as kind of like this disk IO thread. That way, slow disk performance doesn't affect the database performance. That's especially important if you have append-only file every write. Now that favors performance over durability because of the asynchronous replication, but your developers, or you as developers, can use the wait command in your code to favor durability. And basically what that says is wait to confirm this write until it's been persisted. Still possible to lose data, but as long as the client code hasn't been told, yeah, we got you, it doesn't think it's lost data. It just figures, oh, sorry, my request didn't go through. Additionally, we optimize the AOF rewrite frequency, the chunk size, a few other things like that. All right, now here's a bunch of the processes that are running, but right now I just want to talk about the REST API. All right, the RESTful API makes it possible to automate, well, everything. But wait, there's more. It also allows us to make an admin GUI, including shown here, these metric views. Now, in addition to a scale selector at the top of the page, not shown in this slide, I've got it in the next one, that lets you set the scale of the x-axis, in other words, time. And then in each of these metric graphs, you can choose which metrics to display up in the larger side-by-side comparison. Enterprise also expands on the role-based active access control that comes out of the box with open source. So you can specify your users and then the roles for those users. You do not need to give each user access individually. You can specify a role, and then a bunch of users can be in the same role and they'll have the same access. Our enterprise ACLs take the same format as the open source ACLs, and you can integrate with LDAP. So in summary, again, this is just the feature summary. I'll get to the development part like the title promised. Redis Enterprise has a shared nothing symmetric master replica architecture. It segregates cluster management from data access so that administrative operations don't impact client, or in other words, database performance. That's why databases can be scaled out on demand and highly available. A proxy layer is provided to improve performance and decouple client code from changes to the cluster database topology. It has a distributed cluster management system built for resiliency. Each node's processes can be monitored individually and traced for health checks, and admin actions can be performed via the management UI, the REST API, or a command line interface. But you came here for programming. So let's talk now about programming. So Redis data structures use unique layouts and operations amongst themselves, that is, for storing and accessing data efficiently. They're not as general purpose as database tables and records, but they can be a whole lot more performant. And they typically mirror the most commonly used data structures in programming languages. That's the main benefit. It's simple. It mirrors your programming data structures. No schemas, which also technically means no free-form searches, like with a relational database, no secondary indices, like with a relational database. But because these are the same types of structures you're using in your code, it gets easier to program. In fact, there's even a word for it, impedance. Impedance is a word that refers to the extra time and effort that you as developers need to put in to translate and maintain the differences between your native coding structures like strings and lists and sets and relational tables and SQL queries. So each data item then consists of a unique key and an associated value. But those keys and values, the values don't always have to be strings. The values can be, for example, a hash, which will work just like a hash map in Java or a Python dictionary. Key value fields that allow you to do atomic transactions on the individual values, key value pairs within the hash, or a set that functions like a set, right? Why are they useful? Well, they're fast, they're compact. That's what allows you to use Redis as a database, a cache, a message broker, session store, queues, stacks, time series data, geospatial data, and even add search on there. And then technically, you could say that Redis is infinitely extensible. There are dozens, if not hundreds, of modules already out there. Redis, the company, maintains several of them. We call them Redis Enterprise modules. We make them available, source available. But if they don't do what you need, you can write your own. These are some of the popular ones. Specifically, we're going to be taking a look at JSON and search in a little while. Before we get there, let's take a look at some typical use cases. A cache, a simple cache. You know, for some of you, this may be it. This is what you do. The primary use case in your field. The original reason Salvatore Sanfilippo wrote the open source project. Because it's really simple to set a string and get its value. Where here, I mean, what's an HTML document but a really long string? So you can set it in cache, you can get it from cache, you can set an expiration time. You don't need to set the expiration time separately. You could also have an argument for EX for expire and provide a time in seconds to expire, or XAT, EXAT, and a timestamp for expire at a particular time. And then, of course, you can delete it. For example, if a session times out or the page is no longer needed, whatever. Then down here, I know not all of you are Java programmers. That's okay. This is just an example. There is a Java client library called Redis, and Redis has, like most of the client libraries, it has, to the extent possible, tried to keep its methods the same, with the same names as the basic Redis functions. Same thing with Redis Pi, a lot of others. So that simplifies your programming task when you can look at the redis.io documentation and get a pretty good guess at what it is. You could also use Redis as a session store. All right. Now for session store, hashes are really good. This way you can maintain multiple fields and values for your session. Just like set and get allowed you to set set strings and get strings, we prepend with an H for all of the hash commands. So let's say, for example, that you've got a session and you're storing the user ID, name, IP address, and the number of hits. One of the nice things about using a hash as a session store is the user comes back, we want to register another hit. We don't need to pull the whole hash out, add 1 to hits, and put it back. We just increment by to increment by a value, in this case 1. Or also, because these hashes are schemaless, if there's another field, let's say last page, last visited, you simply set it. So set with the key and then the new field and value will add that to the hash without messing with any of the previously existing data. You no longer need it. You can do an del to get rid of just that one field, or a del, as in delete, to delete the entire hash. For example, the session expires or the user logs out. You can also use Redis as a queue. Maybe you have worker processes, or perhaps physical human beings. Some of us are still human beings. We're not Terminator yet. So real human workers pulling support tickets, let's say, to work on. Either way, whether it's machines or people, a queue can do this job. You can do it with a list. So push will push an item onto the left side of the list. Push pushes it onto the right. You can use move to take it off of one queue and put it on another. And so that could look something like this. So let's say you've got these jobs, blue, green, orange, you pushing them onto the queue as it happens. And let's say you've got this urgent job that, hey, let's go ahead and call it red. You can push that so that now it's on the tail of the list instead of the head. Then you can use an move to say, okay, now somebody's ready to handle this ticket. Move the last item from Q1 and make it the next item in Q2 atomically. And then, of course, if you push from only one direction, only push, you've got an append only list. Or if you push and pop from the same end, you have a stack. So same idea. I don't have coding examples for this because it's self-explanatory. Let's say you want to do recommendation. People who read this article also read these other articles. And you want it to be real time, not just data mining, all right? Or similar purchases or dissimilar purchases, recognizing fraud, all right? Sets will do that. So just like with hashes, we preceded all of the commands with H. For sets, we precede them with S. And you can do all of the typical set type functions, such as intersections and unions, or check for membership by doing it is member, or S members to get all of the members in a particular set. So that might look something like this. As people are reading articles, you are tagging them. So tag 1 is article 1 and article 3. Tag 2 is 22, 14, and 3, tag 3, articles 9, 3, and 2. At any time, you or your code can come in and say, okay, which articles are in tag 3? And you'll get the results. But you can also query, all right, now, which articles are in all 3 sets, by doing an S-inter, an intersection of the sets. And in that case, article 3 is the only one that's in all 3 sets. So in other words, has all 3 tags. Some additional common commands for sets, an intersection, S-inter, a union, S-union. Now, in this case, Russia is in the Europe set and in the Asia set. So when we do a union, Russia shows up, but it only shows up once, because the result of an S union will itself be a set, and sets have only unique elements. Or you can do a diff, S diff, Asia and Europe will give you everything in Asia except Russia, because that's also in Europe. Excuse me, everything in Asia except Russia, which is also in Europe. Yes, I know Turkey is also in Europe and Asia, but it's not in these sets. Haven't gotten to the step of adding Turkey yet. Leaderboard. A whole lot of massive multiplayer online games use Redis, either the open source or the enterprise, for their leaderboards. So you've got a situation where you have lots of users playing a game, collecting points, and you want to display real-time leaderboard. Obviously, disk-based is too slow. Sorted sets will allow you to do that. Now, the S was already taken. So we're going to do a Z add, Z range, or Z rev range, reverse to get descending order, or Z rank. Well, if you're in the United States. If you're in Canada, UK, Australia, pretty much anywhere else in the world, you're going to use Z add and Z range and Z rank. And so that might look something like this, where we've got these users that have these scores. The sorted set automatically ranks them. Then let's say in game 1, player 3 kills an orc and gets 10,000 points. Okay, 10,000 points is a bit overboard for an orc, but you get the idea. So Z incr by will increment by the value supplied, which not only changes the score for player 3, but also adjusts the rank behind the scenes automatically. So now player 3 is on the top of the leaderboard. You want to know who's the top score? Z rev range. Rev as in reverse, because you want descending order. You want to know who's on top, not who's on first, who's on top, what's on second. I don't know. Anyway, so for game 1, you query that by saying 0, 0. In other words, give me the 0th, the first entry to the first entry. You want the first 2 entries? No problem. Just request Z rev range 0, 1. You want to get them with scores? With scores. I mean, how easy does it get, right? Now, there is a special use case for sorted sets, and that's geolocation. So a geo set is a sorted set where we have an algorithm that's going to take the longitude and latitude and turn it into a single numeric value, which will be then the score for that location, let's say. So geoadd adds location, geodist gets distances, geosearch can search within the set. And this solves a problem like, hey, where are the pharmacies within 2 kilometers? Or let's talk a little bit more real time. Where's my rideshare? Where's my delivery truck? It's public knowledge that Uber uses Redis database. Because of course when you are getting a ride on Uber, your phone is not talking to the driver's phone. Your phone is talking to the Uber database. The driver's phone is talking to the Uber database. And you're expecting real-time updates to how far away your driver is. And that's got to happen fast. And geosets make that happen. So let's say hypothetically you load your database. In this case, we've got a customer that has their smartphone. This is the pharmacy list. They've just asked for pharmacies nearby. So your client code writes a query something like this: georadius pharmacies within 600 meters of the GPS coordinates that your customer shared with you. Now, from this particular location, there's only one within 600 meters, and so that one gets returned. Because we asked for with distance and with coordinates, we get the distance 511.7 meters and the coordinates, which then you can pass off to your mapping software so that it can pop up a pin, and the customer can see how far they are from where they need to be. All right. Pub sub, we do that too. You have service to service notifications. Pub sub, for example, is one of the primary ways that Redis nodes communicate with each other, by using Redis pub sub. All right. Such as apps sending out messages about activities to multiple users, or services communicating with each other, you can use pub sub. The commands are publish and subscribe. So clients subscribe to and receive messages from channels. Publishers publish to channels. The subscribers don't need to know anything about the publishers. The publishers don't need to know anything about the subscribers. And of course, subscribers don't have to interact with other subscribers. And they won't unless a subscriber also publishes to that channel. Additionally, besides, so what we showed was in the previous slide was multiple publishers to the same channel, but you can have a publisher publishing to any number of channels, and subscribers who subscribe to however many channels they need. So hypothetically, you could have a weather app where the publisher is publishing current weather reports to a bunch of different channels. Let's say, for example, weather Stockholm, weather Madrid, weather Boston, weather whatever. And then you've got, let's say, a user's app in Stockholm that is subscribed to only weather Stockholm. So that user is only getting the Stockholm reports. And let's say, hypothetical, you've got a user in Madrid that's subscribed to weather Madrid, and they're getting only the Madrid reports, and so on. Now, with open source, publishers can publish to any shard, and subscribers can subscribe to any shard, which means that anytime there is a published message, it has to get propagated to all of the other shards in the database. With Redis Enterprise, we make use of the proxy. And so we hash the channel name just as if it were a key. I'll talk more about that hashing and that key in the next section. But we hash it just like it was a key, which means it is officially linked to one particular data shard. So let's say we've got this blue channel, channel X, which hashes to shard 1. Publishers can publish to the proxy. The proxy takes care of making sure that channel X gets on shard 1 and channel Y gets on shard 2. Then the subscribers, again, they're subscribing technically, or in essence, to the proxy. And the proxy takes care of getting the data from shard 1 or shard 2 or shard n, whichever is appropriate. And that way we have a lot less internode, intershard communication to handle and use and take up overhead. So speaking of shards, what does that mean to you as developers if you have a multi-sharded database? Let's find out. So first thing, why? Why are we sharding? It allows you to distribute your data across nodes, which allows your database to exceed 25 gigabytes and 25,000 operations per second. 25 is not a magic number. It's just over years of experience. We've seen that on average, a single Redis open source instance can handle about 25 gigabytes of data and 25,000 operations per second while still maintaining sub-millisecond latency. By sharding out like this, your database can handle a lot bigger volumes. And I'm talking tens, even hundreds of terabytes of data. And high write throughput, as in millions of operations per second, while still maintaining sub-millisecond latency. The default function is a hash where we do a CRC16 algorithm on the key itself and then modulo 16K. So now your data is in these hash slots. The algorithm gives you a practically random distribution of data. And then that data goes into hash slots. So if you've got 4 nodes, hash slot 0 through 1 less than 4K goes on shard 0. Hash slots 4K through 1 less than 8K goes on shard 1, and so on. So each node has exactly a quarter of the hash slots, which corresponds to approximately a quarter of the data. So this hash-based algorithm, as I mentioned, is on the key itself. So we do that CRC16 modulo 16K. That gets you a fixed set of slots that are evenly distributed and easy to rebalance. Now, let me take a brief side trip here to talk about the keys themselves. Because this is not a relational database, you don't have that option of, foreign keys. You can't say, hey, go to the course table and find the math department, the reference to the math table, and then find me Math 101. But you can build those relationships into the naming convention. So for example, you could name your key course : math : 101 to express that this 101 is a math course, or task : pending : 11. So 11, job 11 or ticket 11 is a pending task, or ticket 14 is a completed task. You can even have one to multiple relationships. So for example, student 1 is in class 456. Student 2 is also in class 456. And then you can set these depending on what you're using it for. You can also give any of those keys a time to live, an expiration. Now, if you've used open source clustered Redis before, you've hit this wall. If you haven't, all right, let me just warn you, there's a wall ahead. Multi-key commands only work if everything's in the same hash slot. And that's because of the way that Salvatore originally architected the database. And it's not an accident. It's intentional to make things fast and simple. So, for example, all of these multi-key commands will only work if all of the items are in the same hash slot. Also, transactions, which we'll talk more about in a little while, which is, a multi-exec block. Everything within the multi-exec block, and if there are any watched keys, all of those watched keys need to be in the same hash slot. A Lua script, anything that happens in the script has to be in the same hash slot. A Lua script only runs on one shard and only operates on a particular hash slot. So what's a developer to do? Well, some things we take care of for you. So one thing that doesn't work in Redis Enterprise, but doesn't work in open source, but does in enterprise, is we actually make use of our proxy to do a few variadic commands. So for example, you can do a delete on multiple keys. In open source, that delete, all of those keys you're deleting have to be in the same hash slot. Again, this is if you have a clustered database. If the only thing you've ever worked with before is a single open source instance, you may think I'm lying to you. I'm not. It's just, this is the next layer of complicated. All right. Also, a multi-set and a multi-get. All of those keys need to be in the same hash slot. With enterprise, we recognize that these commands for multiple keys, they don't really logically need to have everything in the same hash slot. They just technically need it. So instead, when these commands get to the proxy, our proxy says, oh, this is a multi-get, this is an mget. I'm going to parse these out to the various shards so each can take care of its own get. But there's a whole bunch of other stuff that you're going to want to do that's not going to be one of those three commands. So you can use hashtags. Now, by hashtags, I don't mean, hashtag having a great time, hashtag Data Innovators Conference, hashtag whatever. I mean these tags, which are actually curly braces that surround part of the key. And then that tag becomes the only part of the key that is run through the hashing algorithm. Okay, and it's got to be curly braces. If you try using a Mo brace or a Larry brace, it's not going to work. That way you can have something like, for example, users : hashtag and then the user ID, events : hashtag user ID, messages : hashtag user ID. And because the user ID is the only thing that's going through the hashing algorithm, all three of these will end up in the same hash slot. Here we're saying hypothetically slot 2, 3, 4, 5. What are the chances that'll actually happening? Well, 1 in 16K. So for example, user 555, if you want to simultaneously add a user alert to a stream, that's what xadd does, set a user message in a string, and update the user status in a hash, and do it in a single transaction by putting it in a multi-exec block. That's what turns this into a single transaction. All you need to do is hashtag the user ID. And now all of these commands are going to hash to the same slot. Let me show you what I mean by that. So I'm going to switch over here to my, there we go. So I have a database set up here. This is Redis Insight, by the way. It's a free tool. So I'm now connected to my database. I can come in here and look at all the keys. This is data I preloaded for a later demonstration. It's just got some hashes of some, hypothetical real estate. I can also go to open up command line by simply clicking on the CLI here, or by going to the workbench. Either one will get me a command line. And let's say I want to do that, a multi-exec. So even something like multi-set hello world. And notice, by the way, that it is queued. That's the way multi-exec works. It always queues the request, and then it's not going to execute them till I get to execute. And then let's say I also want to set greeting world or greeting planet. Let's just make that a little bit snazzier. I get a cross-slot violation. These keys aren't in the same hash. So let me throw that out. Discard is the command to get rid of my transaction. Similar idea if I try to do this with sets. So let's say, for example, I want a set that is sets colors primary, that has the primary colors, red, blue, green. And I want sets color secondary with the secondary colors, cyan, magenta, and yellow. Now, those did get saved because each of those, this wasn't multi-exec, each of those was a separate operation. The sets got stored, but if I want to do a union of those sets, I can't. I get a cross-slot violation. So what can I do if I need to do unions? Well, I can use hashtags. So for example, I could say set add and now put colors in hashtags. So labs : sets : colors in hashtag : ink, cyan, magenta, yellow, black. And I just stored 4. And then I could do colors lighting, let's say, to keep the theme, and red, blue, green. If I want to do a union, then it will work because both of these, the hash slot is based only on COLORS. Yeah, I know. Those of you in the UK are saying, I spelled it wrong. Trust me, this works in America. And so now I have an S union. Similarly, I could create, let's say, colors of the rainbow set. And that way I can do an intersection. I had to do another set because ink and lighting don't have any intersection. So I could show you a union, but if for an intersection now, colors of the rainbow and colors lighting will get me the intersection. S inter gets me blue, green, and red. All right. And again, I could do unions on that. I could do whatever I want with those sets, multi-key commands, because they are all in the same hash slot. So let me get back to my slide deck here. One of the ways that you can extend functionality of core Redis is with modules. In particular, I want to talk about Redis JSON and Redis search. Starting with Redis JSON. Redis JSON allows you to implement the JSON as a native Redis data type. It is completely compliant with the JSON standard, ECMA 404. I kind of wish they had skipped that number and go to 405. Well, that's not much better, but every time I see that 404, I think it's not found. Anyway, so the full JSON standard, including JSON path-like syntax for selecting elements inside of documents. All right. They're stored in a binary data in a tree structure. And that's what allows you to get access to the sub-elements and sub-sub-elements and so on. You can also perform typed atomic operations for all supported JSON value types. Now, you could store a JSON without the module, but to do that, you would have to either stringify it, serialize it and store the serialized form as a string, or decompose it and recompose it into a hash. The disadvantages of doing it with a stringify is then element access is impossible. You have to get the entire document, deserialize it, do your stuff, reserialize it, and save it. Modifications are not atomic, therefore, and there's a bunch of memory overhead. With hashes, a bit better. At least you can now get to elements, but those elements can only be a string or a number. And I have number in quotes here because technically all of the hashes values are strings. But if that string can be parsed as a number, you can do numeric actions on it. So there's no nesting. You can only use strings and numbers, and there's still that memory overhead. Not to mention the processing overhead if you need to get to something that got serialized so you could store a sub nest. So why use it? Well, now you can atomically perform operations on the individual properties without the overhead of loading the entire document. There's no extra memory required, no extra network bandwidth. Nested JSON supported, multiple data types, basically anything that JSON supports. So now for the rest of this section of the slides, for the rest of this JSON discussion, this is the JSON I'm going to be talking about. So it's got string, it's got number, but category, notice, is itself a JSON. It is a nested object that has two properties, ID and name. Tags is an array. So to create the JSON, it would look something like this. JSON.set product:1. So this is saying that's the key name. I want to start from the root. In other words, this is my new JSON. And then the JSON object where, ... means, etc. The rest of the stuff from the previous screen. Now, so just like set and hset, JSON.set is used either to make a new one, as shown here, or to update an existing one. So, for example, to get an item, to get the whole JSON object, you could do JSON.get and then the key. To get a particular value, JSON.get and the key, and then the path to that value. Similarly, to set this, to change its value, it would be JSON.set, product:1, $.name, and then the new value. If it's a nested property, you just use the JSON path format. That'll get you the category name. If it's an element in array, JSON path format, such as, root.tags brace 0, brace 1. You can also append your array atomically. So this is going to go to products:1 and append the tags array with the value Bluetooth. You can increment by. So this is going to increment the price by 10. If you want all of the key values in a particular path, for example, you want both ID and name for category, JSON, well, this obj keys is just going to get you the keys from it, not the whole values. Get would get you the key and the value. You just want to know what your keys are, object keys. So let's head back over to my demo area here and take a look at some JSON. So first, I want to point out this is some JSON that I've already added. I preloaded with about 180 imaginary properties. Presumably those locations actually exist. I just don't know if they correspond to the addresses. So let's say I want to set a new one, and I'll just use the CLI here so that I can stay on this same keys page. And I want to set a property. Property 42. Property name is residential 42. The address is, now my address, you'll notice, is a nested object. So address has street, city, zip, and state. So address street is 0001 Cemetery Lane in Elk Grove, California, 95624. It's got 4 beds, 2 baths, 1 dungeon, 1590 square feet, etc. I execute that. It says okay, which means I should now be able to find property 42. Unless I had a typo. I didn't have a typo. So there's the property 142, since I did star 42. And here's my new property 42, residential at this address and those conditions. I want to know, well, what type is that? What's the data type I just stored? The command for that is type. And it's Redis Enterprise JSON. I want to get all of the values. I can do a JSON.get. I want to get just the street address. I can do a JSON.get and then specify $.address.street. Want to know the sale price? Hey, no problem. Just ask. I want it, let's say it turns out that the property is haunted, and so we need to knock 10 grand off the price. Or I don't know, maybe we should be adding 10 grand if it's haunted. But in any case, there we go. We do an anchor buy on just that one field, and the return value is the new price. All right, let's talk Redis search now. Because one of the nice things about JSON is it can be indexed by Redis search. So can hashes. Hashes and JSON are the 2 document types that you can index with Redis search. What is Redis search? It is a source available engine for querying, indexing, and full text search for Redis, built as a module. What can it do? All of these things. So, for example, you can query numeric ranges like prices or delivery dates, query tags, values such as size or color, geo queries, store locations, customer locations, delivery truck locations, aggregation, show how many blue dresses are in stock, or what's the average price of a widget. Document ranking, using term frequency, inverse document frequency, to figure out which words are more important in a product search. Field weights for which fields are more relevant to defining a match, like a product match, for example. Auto completion suggestions with fuzzy prefix suggestions. I mean, this is practically a required to play feature for online searches. Spell checking based on dictionaries or known words in a full index. Same idea, required to play. You can also do complex Boolean queries, and, or, not. Find this product that is size extra large and color blue, but not something else. And then, of course, you can do aggregations that are specific to internal consumption for your business units. The way that'll work, the way that it'll look is you have a collection of documents making up an index. So the documents themselves are stored in your Redis database. So doc ID 1 and doc ID 2, for example, we're saying hypothetically that's the key name for these hashes. Then you have an index that has these document IDs and indices for the fields that you specify. Now, not all documents need to have the same fields. Redis is still schemaless. So document 2 has a color and document 1 doesn't, no problem. And we can even have an index on the field color. That's okay. And document 1 just won't have that field index because it doesn't have a value. Index structures defined by a schema. So, wait a minute, Tom, you just said this is schemaless. Yeah, the document is schemaless, but the index has a schema. And we'll show you in a moment how to define that schema. That schema says how your fields are going to be stored within the index and what gets indexed. Now, ever since version 2.0, Redis search automatically indexes any key value pairs, any documents that match a key pattern. So it'll look something like this. Let's say we've got a bunch of documents that represent e-commerce products. So we're calling our index e-commerce-products. We do that. We create it with an ft.create. You specify what type of document. It is either on hash or on JSON. And then you specify a prefix. In this case, we're saying only one prefix, product : but you could specify 2 prefixes by putting a 2 there and say, product : space user : or whatever. And then the schema is simply, these are the fields I want to index. Name is text, price is numeric, and color is a tag. Optionally, you can make a filter. Now, this isn't a search filter. This is an index filter. So this is saying only index hashes whose key begins with product : and whose price is over 1,000. So, only index expensive products, or only index active customers, only index open support tickets, only index whatever. So this filtering is actually at index time to say which documents will get indexed. And then the same schema in this example. Now, the previous slide would look like this if your documents were JSON. So instead of on hash, it's on JSON. And then for the schema, you give the JSON path to the field. So $.name, and then you can also do a aliasing. So $.name as name means now in my queries, I just have to search for name. I don't have to search for $.name. This is more important if you've got nested. So for example, $.address.shipping.street as street, or as ship street, or as whatever else is meaningful to you as a developer. Then your queries can simply look for shipping street instead of looking for $.address.shipping.street. These are the field types. Also, by the way, not shown here, vector similarity search, kind of an advanced feature, not covering it today. But you can have number fields, geo fields, geospatial locations, tag fields. Think of a tag field kind of like a set of strings. So they're string values. It's a set. It's not an enum of string. You don't have to predefine all of the values. It's just a set. But the assumption is that it's low cardinality. Colors, this particular product comes in. Sizes, this product comes in. That sort of thing. And then text fields are normal text fields. Now, they're all transformed to lowercase. I don't mean we're rewriting your document. I just mean in the index and in the queries, we transform to all lower. And in effect, that gives us a case-insensitive search. So it doesn't matter if you're shoppers or if you're drivers or you're whatever, searches for something, mixed case, low case, uppers, whatever, doesn't matter. We'll find it. They are tokenized and they can be weighted and sorted. In fact, let's take a look at the general options. So any of the fields you can specify if it is sortable or not, and or if you want to exclude it from the index. No index says, hey, don't even index this field. For tags, you can specify the separator. Is this a comma delimited list, a semicolon delimited list, and so on. With text fields, you can go even further and specify the weight or no stemming, which is to say that it won't take the endings off of words. So if I say no stem on product name, that means if the shopper looks for swimming suit, the search is going to be swimming suit, not swimsuit. Or even phonetic. If you choose phonetic, you have to specify the dictionary. So here, short description, we're saying we want to index that phonetically, and so we have to specify which dictionary to use. So here is similar to the previous examples, but now more complicated. So this is showing several more fields, several of them being text fields. And here what we're saying is that the name is the base calculation, and so is the short description, weight 1.0. Weights are always between 0 and 1.0. The type of product is half as important. The long description half as important, presumably because there's going to be a lot of noise in the long description. The manufacturer is half as important. Now, when I say half as important, this weighting does not change whether or not something gets a hit. All right, so a hit, a match, is based on, is the text found? This weighting is for the return values. What order are they in? That's the importance of the weighting. Sortable, price, for example, means for actually, and skewed, so the two that are sortable, I can say, type is also sortable. Anything that says sortable, let me, our three secret weapons. No, anything that says sortable, you can give, for example, your shoppers the option of sorting by price, sorting by color, sorting by type. Anything that's not sortable, don't give that option to your shoppers because it's not built in. Which fields to index? Well, you ask yourself questions like these. Notice that these are really kind of business questions. So you as developers need to coordinate with your business analyst or product managers or whatever other job titles, whatever other people are involved in the marketing of it. So depending on whether you're doing an e-commerce site or a blog site or some other sort of how-to site or an app, or depending on what you're doing, you need to think about, okay, how do I get to the right document? And how do I, meaning me as the final consumer, in the role of the final consumer, how do I recognize that I have the right document? And that's your starting point for defining your schema. From time to time, you may need to alter your schema. There's a command for that, ft.alter. So here in this example, we are adding available stock as a numeric sortable field. To add a document, when you add a document to the index, you add a document to your Redis database. That's it. hset product:1, the system recognizes, oh, this is a hash. It matches the key. I put this in the index. Or if we did JSON set product:1, this is a JSON. It matches my pattern. I'm going to put this in the index. I meaning, the computer speaking. Every time you modify a document, the index gets updated. Change the price index gets updated. Every time you delete a document, the index gets updated. Now let's talk from the other side, the querying. ft.search, specify the index, and then field name : value. We'll search for TV in the name field. At price colon braces 500 to 1000, we'll search for this numeric value in this numeric range. So for example, if you do this search, we're saying that from our hypothetical sample data, there are 12 products that meet that criteria. This is the first one, product number 1850123, and here are its values. You don't have to do an inclusive range. You can do an exclusive range or an unbounded upper or lower range, an exact equal, the syntax on this slide, and of course, in the documentation. To query tag fields, you need to use the curly braces. All right, so color, for example, in our schema in the previous slides was specified as a tag. So we're only going to match on black the tag value if we put black in these curly braces. Why would you want to do that? Well, it can expedite faceted searching. It's not required for faceted searching, but if you do this sort of, tagging, you can give your customers the option of saying, hey, I want color black and color blue, or size small, style polo, whatever. For full text search, simply don't specify the field value. So this is going to look for, for geospatial, I was getting ahead of myself. For geospatial, it's square braces because it's a numeric value, and then the coordinates followed by the radius, and then the units. And these are the only units: meter, kilometer, mile, foot, these abbreviations exactly, case insensitive. For full text search, just don't specify a field. This will look for the string TV in any text field. By default, space between two queries means and. So this is color black and price in this range. This is TV in any string field and 4K in any text field, any index text field, of course. If you want, or you write your query with the pipe, the bar, whatever you want to call it. You can put it within the tags, the curly braces if you're doing tags. So this one will look for TV in any text field, index text field, and smart in any index text field. Negation, you put a negative in front of the field name. So this is saying, get me anything, but color can't be black. For full text search, you can do it on the individual things. So for example, this is saying, give me TV, but not smart TVs. If I wanted it to be the literal string, I would have to include it in strings and then escape the inner quotes. I mean, include it in quotes. So this is saying, search for quote, a literal quote, bright space star, a literal closing quote, and then close quote for my request. Just as if this were Linux. Why? Because it is. It is Linux. Your Redis database is running in Linux. You probably noticed that when you downloaded it. All right, so then field weight, again, as I mentioned before, this is just for placement. But you can actually set values on entire documents. You can set a document score. So if you're collecting blog posts, let's say, and you want to score ones by staff as one by documents by known users at perhaps 0.8, newbies 0.5 or lower. That's the idea there. And so you would set the doc score. Additionally, you can do other arguments like limit, for example. This will allow you to paginate your results. And you can aggregate. So this is saying, go to e-commerce products, find everything, group them by department, reduce that result by count distinct on the SKU and call that the count. And then sort by count descending. So in other words, give me a list of the departments and how many items of each unique SKU is in that department. And then last but not least, what I want to talk about, another feature is with Redis open source, a search is done on a single shard. With enterprise, we make use of the proxy. So the query comes into the proxy will go to all of the shards and ask their index. Hey, what documents do you have that meet this query? And then it will collect those up and return them to the app. So I got a demo and I've gone a little over time, so I need to keep my demo short, but this is a sample of the JSON. So I'm going to be working with that same, I'm doing a search on that same JSON structure we saw for the previous real estate. And this is the schema. I have not added this schema yet, but I'm going to index these. I'm going to index address.street as street, address.city as city, and so on. So the idea here is this is a realtor's app. So real estate agents can quickly search for properties that meet their clients' criteria, or shoppers, perhaps real estate buyers, can go on the website and search for things. So let me head back over here. Once again, I'm on the command line. So to create that, I'm going to simply enter the ft.create with all of those things that I just showed you on the slide. So now I've got an index. I can search the real estate products index for properties in Sacramento with 3 beds, 2 baths, and at least 1,000 feet. And the result are these. And in fact, let me switch over here, because what's going to be really nice in this one is the graphic interface. So I just did the same search, and now in this search, the output is going to show up in a nice table. I could say maybe I need to narrow it down. I want just those properties that have a garage. So this is going to look for garage in any text field. And now I'm down to a smaller list, 5. Let's say I want garage and swimming pool. Hypothetically, that would look like this. So now I want the exact string swimming space pool. So I need to put that in quotes and escape the quotes. Garage, still in Sacramento, 3 bedrooms, 2 baths, 1,000 or more square feet. And let's say I want that to be within 5 miles of my favorite park. So that's narrowing it down even more. And that gives me these 3. So these 3 have garage and swimming pool and are within 5 miles of the geolocation for my favorite park. Now, notice that there's no heuristics here. So no swimming pool matches on swimming pool. I search for a literal string. So then it'd be up to me as a developer to take care of that a little bit better. Or I can do aggregations. Let's say hypothetically that I want to get all the real estate products in the city of Sacramento that have 3 bedrooms, and I want you to group them by number of baths, which is pretty boring in this case. This is all going to be 3, but just hypothetically, zip code, and then get me an average of the sale price and call that average price. Then sort it by the number of baths. In fact, let me, oh yeah, that's 3 beds. I'm sorting on baths, not on bedrooms. Let me read my read my writing. Yeah. So then I execute that, and the result is here. So I've got this generated alias, which was necessary for the calculation. And then I've also got the zips and the average price and the bath. And like I requested, they are sorted by number of baths. So just some general examples of searches. You can get, of course, much more complicated. And in fact, I'm going to turn it over to Al now, who has a more realistic, a more real world example.
Thanks, Tom. Hi, everybody. I am going to transition to a laptop to do a little demonstration for you. Let me share my desktop. Actually, Tom, if you would stop sharing.
Sorry, I have
should
to
be all
stop
set.
sharing for you to do that.
Terrific, thank you. Okay, everybody. So Tom has covered quite a bit of material, and what I want to do is see if I can tie it together for you by essentially running a few applications that are taking advantage of Redis and the modules to give you a feel for what a robust application would look like with Redis as a database. Now, before I get started, I did want to show you the data sets I'll be working with. The first one is just something I downloaded from the internet. It's an HR employee data set. It looks like this, right? Just a simple spreadsheet of data, more than enough to make for an interesting demo. So we're going to leverage this for doing some Redis core operations and Redis search. And on the right, I am going to work with JSON documents. So what you see there on the right is product documents. I had downloaded them from Best Buy a couple of years ago, but the idea is still the same, right? You've got lots of product information, which are terrific data sets to work with when you want to do filtering, which I can show you with Redis App Studio itself. So what I'm going to do is just stop sharing here for a moment because I want to isolate in on the specific web browser window that I will do my demonstration from. And then after that, we'll go through all the functionality. So we are going to share this. And this is our application window. And before I get started, for those of you who do tinker out there with open source, let me first tell you a little bit about the demo itself in terms of how it's running. I'm leveraging Redis Stack. I've got Docker Desktop on my laptop, and I'm just running Redis Stack in the background. That is a super easy way for you to gain access to our stack and to have the ability to not only do core Redis operations, but have access to all our modules as well. What I'll be demonstrating is Redis App Studio, which is a suite of applications that exercise Redis Core, Redis Search, Redis JSON, Redis Graph, all part of the application I've got. I'm just going to focus on Search and JSON and Core, but if you do want to play with Graph, you'll have the ability to do that. All open source. If you're a Java developer, dive in, work with this. You can learn from it, and hopefully it gives you a great jumpstart working with Redis. And I just want to let you know, Redis just supports many programming libraries. I'm using Redis, one that we support, but there are many out there for Java, Python. If you're a .NET developer, lots of ways for you to get access to those types of programming environments. So now what I'm showing you is the entry point into Redis App Studio, and it's literally an application launcher. So let's get started by working with some of the data that I just walked you through. We're going to grab that HR employee spreadsheet, and we're going to load it up. And the first thing we're going to do is load it into a data modeler. And that is how I would define it. So essentially, I give it an app name, and I give it a prefix. And the prefix in this case is going to be used just to delineate the namespace when the application gets created. And from this, what it's doing is it's generating the application, and it's taking that data set, which is effectively that spreadsheet I just showed you, and it's just loaded it in memory here. And we do utilize this tool sometimes when we want to do some data modeling and we're working with a customer and showing them ways that they could model their data. Let's say if it was coming from a relational engine. Now, what I want to leverage though from the data modeler is our ability to save the data in Redis itself. And the first place we're going to save it is in Redis core. So here I am going to create an HR Redis application, and I'm going to prefix it HRC, which not only for the web application, it'll be prefixed in the key space as well. And if you look here for storage type, what we're going to do is take each of the rows that you show in that spreadsheet, and we're going to create hashes with them. And then to simplify the presentation of those rows, we're going to store each of them in a sorted set so that we can easily track the documents that you're working with. So we're going to kick off a generation of a new application. We are now storing these records in Redis itself. And you can see at the bottom left, we get 1,000 of them. And if I just scroll here, this is what Redis is famous for, is its ability to fetch and operate on data very, very quickly. And as you can see, it's quite responsive here. In terms of data sets that are here, this is a row in that spreadsheet that I showed you. It's stored as a hash now in Redis itself. And what I'm going to do is I'm just going to go through some CRUD operations to illustrate commands you can use to manage the lifecycle of data in your application. So the first one is we're just going to add another record. So I'm duplicating an existing one, and I'm just going to give it a unique identifier with the employee ID. And I'm going to call this person Bob Smith. And we're going to save this. And if you notice on the bottom left, you'll see we went from 1,000 to 1,001. And now we've got an additional record. Why don't we go through an edit cycle with this application, and we'll add a different title. And we'll have a different office location. And we'll save this away. And you can see here that it's made the update. And just to complete the operations, I'm going to delete the record and remove it from the database. And the reason I went through those cycles is I wanted to show you a feature of App Studio. It's meant to be a teaching tool. So if you do end up utilizing it, I hope you can use it from a learning perspective. And one of the features you have on the toolbar is the ability to see the command grid. So as I was exercising all of these operations in the application, I was keeping track through using a Redis stream of all the commands that were being used behind the scenes. And you see them here. And if we work backwards, you'll note that I did a removal operation, a delete. So that involved really deleting two elements. One was removing it from a sorted set, and that's what ZREM is. And then the other was actually deleting the hash itself, which is what you see here. Prior to that, we did an update operation, which was the hset command, where we set the position title as PS consultant, and we set the office location as Boston, Mass. So this is intended to kind of teach you, by exercising the apps that we provide, how you could utilize Redis to perform the operations. If you want to learn about the specific commands themselves, just double click on any of them, and it'll take you to our online documentation, where you can get all the details about the commands themselves. And if you remember, hset was something Tom talked about a few minutes ago to explain how to utilize the command when you're storing data as a hash itself. So the next thing I want to do is take you back to the data modeler. And now what we're going to do is we're going to create a new application from here, but this time we're going to create a search application. So now we're going to save this as an HR search application, and we will call this HRS, and we will create it in Redis itself. And what it's doing now is it's rehatting those hashes with a different key prefix. And then it's also got Redis search in the background, tracking all of the hashes that have been created, and it created a search index against it. Now, as you can see, as I'm scrolling through, this continues to be very performant, and this is what Redis is famous for, right? Being very, very quick to get at your data. So some of the things that we can do to exercise this functionality, what I'm going to do is do a search. for the term business. And you can see we've got our matches here. If I enable highlighting, which is a feature Tom showed you, you can highlight the cells in the grid that match the term itself. Sorting is possible, and the way I enabled that in this application was I have a button at the top of each of the columns. If I select it, we sort in ascending order, and if I select it again, we'll sort in descending order. So this can be a real easy way as an accelerator to provide sorting capabilities with Redis itself. Another capability I'd like to show you, and Tom did it with Redis Insight, but I'm hoping I can be more visual here, is to build a criteria and interactively filter our data. So what I can do with this filter builder is I can select from the fields, and the first one I'm going to start with is salary, and we're going to use the between operator, and I'm going to provide two values, 90,000 and 120,000 as our first field in the criteria. And you can see we went from 1,000 down to 200 with that query. The next thing we're going to do is we're going to add region to find people in this salary range in a particular region, which I'm going to favor. Let's see, I'm going to go with is one of, and we're going to select South and West as the regions. And now we're down to about 113 with our results. And then I'll do one more. And this time I'm going to focus on a position title. So I'm going to choose position title. And let's say we'll go with starts with. And starts with account. And execute that. And now we've got that down to a real simple list where we found an employee with a salary range between 90 and 120,000 located in the South or West, and their title has got account tied to it. So real easy way, and as you can see, it's quite expressive when you use Redis Search for this kind of functionality. The other thing I'd like to show you is the schema that's behind this. If you remember, Tom explained that when you use Redis Search, you need to define a schema so that Redis knows which of the fields that you want in the search index and how you'd like them to be tokenized. So here we've got the field names on the left and the data types, the title, which we use for the UI presentation. And then from there, if you continue to the right, you'll see that field weights are specified. We can identify whether we want suggestions enabled, whether we'd like to have highlighting enabled, whether it should be stemmed. In this case, we're not doing anything with geolocation, but we could, and it would be identified there. So here, what I want to highlight is you'll notice that full name has suggestions enabled with it, which is something you can do in Redis. And what we're going to do is test out that functionality. I'm going to get to the suggestion widget, and I'm just going to start typing a name. And here we've got Henry Cotton, and I'm going to just select that quickly. And that's how easy it is with suggestions for you to quickly isolate to a particular document in your data set. So next, what I'd like to do is give you a view of what these commands look like. So I'm going to take you here, and you can see these commands are listed, and you'll see the query one that I did where this one used the salary number range. And this is how Tom showed you when he was walking through the commands, specifying a criteria. So we've got salary number, we've got region, and we've got position title, all specified in the query. Again, just double click if you use Redis App Studio, and you can get to the commands and quickly learn how to leverage them. And of course, with the code base in GitHub, you can learn how we've done it with Java as well. The other thing I can quickly show you is what this looks like if you go into Redis Insight, which is something that Tom walked you through. You can see here that the hashes are available, and here are the fields and the values, right? Very visual. Redis Insight can be quite helpful when you want to interrogate the data in Redis itself. The last thing I'd like to show you is another search application, and this one is going to be based on that product data set that I showed you at the beginning of the demo. So the e-commerce products, this is a JSON document. It's got a little over 1,000 products in it, and we're going to generate a product data modeler. and kick that off. That gets the data set loaded and into memory so that we can start reviewing it and understanding how we might want to store it in Redis itself. I'm just quickly going to go, for the sake of time, and save this as a Redis search application. And we're going to call it product search application. And I'll prefix it as PSA. And last time I didn't enable facets, but this time with such a rich set of metadata with the product information, we will enable it. And we're going to create an application with the left navigation area providing us access to facets. So now we're adding these JSON documents in Redis itself. And in addition to that, we're also generating a search index against it. You can see the 1,067 documents. And again, you can see how quickly it is to access these documents. And that is truly the power of Redis, the performance, the 1 millisecond performance. So our first operation, why don't we go through and edit an existing product? In this case, we're going to edit the Office Season 6 to 9, which is a DVD. And we're going to change it to the Redis Office and save that away. And the reason I wanted to do this was to illustrate a point that Tom made about the fact that if you make a change to any of the core data structures, Redis search is automatically going to follow and react to that change and update its index instantly behind the scenes, which is exactly what we've done here when we made the change to the Office that we created earlier. So the other thing I'd like to show you is how to enable facets. And with that, I'm going to take you here to the schema window. And you'll notice as you look at this version of the schema window, we have a new column called path. And this correlates to the JSON path that reaches into each of the JSON documents to identify where to find the field. And that's what all of that syntax is doing, is it identifies where you find the fields in the JSON document itself. To the right of that, you've got your field weights and you've got your stemming and your highlighting. But one thing I want to highlight here is because we've enabled faceting, I want to highlight that we can now, with App Studio, indicate which of these fields we would like to render as a facet. So I've chosen 3 of them. And now what I'm going to do is just rerun the search, and you'll see those facets there rendering on the left. So that allows us to quickly select, in this case, DVD software, and let's say sports and fitness, and there we are, very, very quickly getting to 12 products with just a couple of key clicks, which is a great way to navigate product data like this. The other thing we can do is, of course, we can do a good old-fashioned search for, let's say, iPhones. And you can see that there's 175 of them that are available here. But I like to filter with this by, let's say, adding color. So I'm going to go update color as an additional facet field. And then what I'm going to do is just rerun the query. Now I'm not seeing color, but I know it's probably below. It just scrolled off. So what I'm going to do here, just to help with the presentation, is I'm just going to configure, and this is for the FT aggregate call, so that it only pulls in 5 values per top level field when I do the query. So if I do that, you see now everything fits nicely in the real estate that I've got. So now I can look for, let's say, an iPhone accessory, a trending case, and in the color of bourbon. And again, super easy for you to find your information through the use of facets with Redis search itself. From here, what I'd like to do is to show you what the commands look like behind the scenes. And as you look here, you'll see those FT aggregate calls. And this is how we're doing behind the scenes, our faceting that you saw. And this one is keying on color. This one was doing department. We had subclass and class. Again, just double click on any of these commands. If you want the online help, it's available to you. And then you also have the ability to see the different types of searches that we did for iPhone and those types of things, which are all part of the history that we've got here. And there's an example of it right there. So the last thing I thought I would show you, which I hope you find helpful, is just what does this look like behind the scenes? Well, if we go back to Redis Insight You can see all the different keys that are there, but I can also isolate by a search index, which is what I'm going to do here. And then I'm going to select the one for the e-commerce products. And if I select any of them, you're going to see the JSON document behind the scenes. And then finally, I'll just do a search. And as you can see, we found the same 175 documents there as well. So hopefully that gave you a great feel for Redis and its modules and how you could, with an app like Redis App Studio, build robust applications to exercise the functionality of the database itself. So with that, I'm going to stop sharing. I think I've left us roughly 5 minutes for questions. And I guess I'd like to leave it open for anyone that might have a question on what we've covered today. Is there anything that we have that we can help you with?
Well, thank you so much, Al and Tom, for that excellent presentation. It is greatly appreciated. I did put up a question. If you would like to have a follow-up conversation with Redis, we have Redis individuals across the globe, so we are happy to connect with you and discuss topics of interest. So please do feel free to reach out and let us know if you would like a follow-up discussion with one of our global colleagues. And that. So with that said, I'm just looking and I don't see any additional questions that you didn't already answer in the Q&A, Al. So thank you everyone for joining today's session. We greatly appreciate your time. We do have a session later on this afternoon on Kubernetes, so feel free to check that out. And then we will have several workshops coming up in May. On May 11th, we have a Redis session management and caching workshop. And on May 18th, we have a Redis search solutions application workshop. So definitely we will send additional information. And if you're curious about other tech talks and webinars and Redis events, you can find that on the redis.com website. But thank you again for your time, and definitely stop by our virtual booth and say hello. We'll be there all day. So pop in and we would welcome having a conversation with you. Thanks, Tom and Elle. Everyone have a great day.